In a truly decentralized architecture, a file upload shatters into thousands of encrypted fragments, scattering across a global web of independent nodes. In exactly 5 days, Autonomi 2.0 goes live as a self-regulating storage network, operating without central oversight. The engineering objective of this system is absolute: lifetime data permanence. Once a file enters the network, the architecture must guarantee its survival indefinitely. Most decentralized storage systems fail this test. They rely on human administrators to fix errors, or external price oracles to dictate storage costs. If those central bottlenecks fail, the data dies. They also rely on legacy cryptography. Researchers expect quantum computing to compromise systems like Bitcoin much sooner than originally modeled, leaving older encryption standards with a rapidly shrinking window of protection. Finally, restrictive hardware requirements block average users from participating. True distribution is impossible if running a node requires an enterprise-grade server configuration. To see how Autonomi 2.0 bypasses these bottlenecks, we have to deconstruct its new architecture layer by layer, starting at the transport protocols and moving up to the application layer. Achieving lifetime data permanence requires removing every centralized coordinator, theoretical dependency, and hardware restriction that could compromise the network's survival. We start at the mathematical foundation of the stack, the transport layer. The standard industry approach to post-quantum security relies on a hybrid model, layering new quantum-resistant algorithms on top of classical cryptography. Autonomi 2.0 rejects this model. Maintaining legacy cryptographic standards in the code introduces proven attack vectors that compromise data survival over a multi-decade timeline. With the deployment of the SORSA PQQ version 0.51 update, the network's cryptographic foundation was completely rewritten. The update removed all classical elliptic curve cryptography. Protocols like ED25519, X25519, and Curve 25519 were deleted from the pipeline. They are replaced by the exclusive use of strict NIST post-quantum standards, ML-DSA-65 and ML-KEM-768. The architecture is absolute. Zero fallback to older cryptography is permitted within the system. As quantum systems advance toward breaking current encryption models faster than previously anticipated, this level of structural strictness becomes a necessity. These standards represent the active, shipping reality of the network today, established well beyond the stage of a theoretical roadmap. Enforcing pure post-quantum standards at the lowest network layer provides the mathematical foundation required to keep data secure against near-term quantum threats. Moving up one tier, we reach the physical node level. Many decentralized networks hit a structural bottleneck here, where requiring specialized hardware or enterprise connections prevents broad global node distribution. For consumer internet connections, the primary hurdle is restrictive home routers that block inbound network connections. Autonomi 2.0 solves this utilizing Symmetric NAT hole punching, which allows nodes behind restrictive home firewalls to connect and receive data. The second consumer hardware hurdle is memory. Processing large file uploads usually requires massive amounts of RAM, which often crashes standard desktop computers. To solve this memory bottleneck, the engineering team implemented a mechanism known as chunk spilling. This comparison shows the mechanism's efficiency. A 4 GB data payload is processed through the network using strictly under 250 megabytes of memory. To further streamline these connections, IPv6 connectivity is now enabled by default across the network. By bypassing restrictive routers and capping memory requirements, Autonomi ensures any standard home computer can operate as a secure participant. Now, the third tier of the stack is network coordination. The challenge at this layer is keeping data alive and pricing storage accurately without human intervention or centralized coordinators. When a node drops offline, the system responds instantly. The data fragments it held are automatically cloned and redistributed to surviving adjacent nodes. This replication process is managed by a mechanism called dynamic chunk audit sizing. This mechanism algorithmically adjusts how aggressively the system audits data integrity based on real-time network conditions. Shifting to network economics, traditional decentralized storage has historically relied on external price oracles to dictate storage costs. Autonomi 2.0 calculates storage cost as the median quote multiplied by 3 per chunk, removing the need for an oracle. This establishes a self-regulating market. As a specific node's capacity fills with data, its price rises naturally without external input. This localized, algorithmic approach allowed the development team to strip out roughly 530 transitive EVM dependencies from the payment pipeline, increasing security. By replacing central oracles with deterministic math, the architecture creates an autonomous network that independently manages its own survival and its own economy. Finally, we reach the top layer of the stack, application and consumers. This is the X0X agent layer, where autonomous AI agents are already operating directly on the network. This adoption is entirely organic, occurring without outreach campaigns or financial incentive programs. AI agents gravitate toward this architecture because they require permanent data environments that operate free from human intervention to function autonomously. To support this ecosystem, the developer documentation and API structures have been overhauled. These environments are now formatted for both human developers and direct machine agent consumption simultaneously. A network architected from the transport layer up for total machine autonomy provides the exact infrastructure AI agents require to build and scale. The complete architecture shows how these 4 layers interact as a single unified system. Foundational post-quantum cryptography is supported by the hardware efficiency of the physical nodes, running advanced math on everyday consumer PCs. Localized pricing logic allows AI agents at the application layer to interact with a mathematically stable, self-regulating market. The wider decentralized storage industry often trades on theoretical capabilities and future roadmaps. The operational philosophy for the Autonomi 2.0 launch prioritizes real use, real data, and functional permanence from day one. Decentralized infrastructure earns its trust through functional utility. By removing central points of failure, legacy cryptography, and hardware restrictions, the Autonomi 2.0 architecture delivers lifetime data permanence. It is engineered for today and mathematically secured for tomorrow.